Okay, welcome to Functions Continued, the day 5 of our notes. Today we're going to talk about plugging into a piecewise function. So in this first part, we're going to look at plugging into piecewise functions. So we need to, for problems 1 through 3, evaluate each piecewise function at the given values of the independent variables. So we're basically going to determine which domain interval the input value belongs in first. So this f of x equals, this shows it's a set of functions. So the 6x minus 1 is used if the x value is less than 0. But the 7x plus 3 is used if the x value is greater than or equal to 0. So to help us keep track of that, I've highlighted the first function in purple and the second function in pink. I will then highlight the given x values in the corresponding color to help us identify which function it belongs to. So this first one, the x is a negative 3. So because the x value is less than 0, negative 3 is less than 0, I'm going to use the purple function for this problem. So I wrote out the f of x equals 6x minus 1, again because the x value is less than 0. Then I plugged in the negative 3 in place of x because negative 3 is the x value. Then once I have done that, I can put the 6 parentheses negative 3, close the parentheses, minus 1 into my calculator, and that will give me my output, which in this case is a negative 19. So that means for this piecewise function, the x value of a negative 3 would be paired with the output of a negative 19. Okay, let's try the next one. F of 0, because 0 is included in the pink function, because that domain says x is greater than or equal to 0, I'm going to highlight this one pink. So to start off here, I started by writing the f of x equals 7x plus 3. Then I showed plugging in, substituting in the 0 where the x is, and then again doing that anywhere in the function where I have an x, replacing it with the input value of a 0. When I put that in my calculator, I end up with an output of 3. Okay, the last one, f of 4, which function does 4 belong with? Well, since 4 is greater than or equal to 0, and you could test it. 4 is less than 0, well no, that's not true. 4 is greater than or equal to 0, that's true. So I'm going to use the pink function for the x value of a 4. So again, because of that, I started by writing the f of x equals 7x plus 3, just so you see which function I am using. And then I subbed in the 4 in place of the x's, because that's the input value, to get out my answer, which would be the 31. So f of 4, the input of a 4, gives me an output of 31. So to start you off for the next function, the f of x equals, the top function is x squared minus 9 all divided by x plus 2. That's one function used for all the x values that are less than or equal to negative 1. And then it's an output of a 6 for any x values that are greater than negative 1. The next part of this video I want to talk about is finding inputs and outputs when we use a graph. So remember, the x value is the input. That's in parentheses. The f of x, that entire part, is representing a y value. That's your output. So points are x comma y or x comma f of x. So the f of x, remember, is just another way or a fancy way of saying the y value. When you use graphs, you need to pay attention to whether they gave you an input or an output. So for this first one, the graph of the function f is shown at the right. We want to find f of 0. So if I look, that 0 is in place of the x. So that means they gave me an x value. So I need to go to an x value of 0 on my graph. Now to get to the function, and the function is this, what looks like a W in this graph. So I highlighted it in purple. Now remember, it does stop at this point right here, but the purple obviously highlighted is a little bit beyond it, but it stops at this value right here. So when I go to an x value of 0, that means I'm not moving left or right at all. So if I can't move left or right, because that would no longer be an x value of 0, I can move up or down to get to the function. So I would have to go up one space to reach the function. So that means when the x value is 0, the y value, the output, would be a 1. The next one is similar. They're giving me an x value because, again, it's in the parentheses where the x normally is when I think of f of x. So they're giving me the input. That means that on the graph I need to go to an x value of 1. So that's right here. Now again, to stay at that x value, I can't move left or right, but I can move up or down. So if I move down, I don't get to the function, so I have to move up. Up how many? 1, 2, 3. That is my point on this function when the x value is a 1. So that means that my output would be 3. For part C here, this is a little different. Now they're giving me the f of x. Remember, f of x is the output or the y value. So they're telling me, well, the output is a 4. So if I go, now I'm moving up 4. So up 1, 2, 3, 4. What would the x value be? Well, again, I can't move, this time I can't move up or down because the y value has to be 4. If I move up or down, the y value would no longer be a 4. So I can move left or right. So I can move left 1. So that means that one x value would be negative 1. However, I could also move right 3. So the other value would be a 3. So I have two values here. So to represent the set of x values, you could write x equals negative 1 and then write x equals 3. Or you can use set notation showing that it's a set of values with these squiggly braces, negative 1 and 3. Okay, I'm going to stop there. We will continue in class. And remember that you want to, when you look at graphs, I wrote a little note here that open circles are undefined. That'll help us with the questions in question number 2 on this page. All right, have a good night.